Okay, hello. Number 26. X plus 2y equals 4. The base of a solid is the region in the first quadrant bounded by the line x plus 2y equals 4 and the coordinate axis. What is the volume of the solid if every cross-section perpendicular to the x-axis is a semicircle? Okay, basically they're just saying here's some region and the cross-section is a known cross-section and it is a semicircle. Okay, so this is one of those things where we just do the integral of the area. Alright, so the first thing is we have to find our region. Alright, so in order to find our region, let's make this into something that we know a little bit better. Subtract x from both sides and then divide the whole thing by 2 and we get y equals negative x plus negative x over 2 plus 4 over 2 would be 2. So, or negative 1/2 x plus 2. Alright, so what's our region going to be? Well, let's see. We know that our y-intercept is at 2, and our slope is negative 1/2, which means we go down 1 over 2, right? Rise over run. So we go down 1 over 2. So it's going to end up being there. So here's our region right there. And it's going to cross the x-axis at x equals 4. So our integral is going to be 0 to 4 of some area dx. Now the area is going to be the area of the cross-section. Now the only question is, what is that area? Well, a semicircle, the area of a semicircle is going to be 1/2 pi r squared. A semicircle is like this, right? Okay. But now the thing is that if my semicircle is like this, right, then the radius of the semicircle isn't the whole thing, right? If the radius of the semicircle will be half of it, because each one is a semicircle, well, the radius of my semicircle is going to be half of the distance, right? Usually, kind of to back up, okay, the area of each cross-section is a semicircle. We know this. So that means this is going to kind of look like this, right? Where it's like little semicircles each way going down. Okay, here's a radius of the semicircle. And you can kind of see, it's kind of like a half cone. It goes down like that. Each one is a semicircle. I hope you guys can see that more clearly. I'll draw a bigger picture. Here's kind of the region, and it's like a semicircle here, and that's the region going down, and it's semicircles. So it's kind of like a cone type of thing, where it's like a cone and it's getting narrower and narrower. And so here's the radius, right? So if this is the region here, this is the height of the region, well, the radius is half of this height. Well, to get that height, what is that? Well, that's just my function. At each different value of x, the height is my function at that x. Well, that's this function right here. Okay? So if my radius is half of the function, then my radius equals 1/2 of negative 1/2 x plus 2. Okay? So just kind of bringing that 1/2 in, this becomes negative 1/4 x plus 1. Alright, now going back into my area equals 1/2 pi. My radius is squared, so it's negative 1/4 x plus 1 squared. So it equals 1/2 pi. Squaring this whole thing, this becomes 1/16 x squared plus, or I apologize, it's going to be negative 1/4 x times 1 is negative 1/4 x, then I double it, right? Square the first, square the last, multiply and double. So negative 1/4 x times 1 is negative 1/4 x, double it is negative 1/2 x. Then square the last is just 1. Okay, so that's my whole function here. That's my area. So I'm taking the integral of this from 0 to 4. I'm going to bring the pi over 2 to the outside. This becomes 1/16 x squared minus 1/2 x plus 1 dx. Alright, so I'm taking my integral. This is pi over 2. X squared, that's going to be 3, x to the third, and then divided. So it's going to be 1 over 48, which is 16 times 3, x cubed, minus, this is going to become squared, and then divide by 2 is minus 1/4 x squared plus x. And then I do it from 0 to 4. Fortunately, we're doing it from 0 to 4, so all we have to do is plug in 4, because 0 is just going to cancel out. So we get 1 over 48, 4 cubed, minus 1/4, 4 squared, plus 4 is going to be our answer. It's pi over 2. 4 cubed is 64, so it's 64 over 48, minus 4 squared is 16 over 4 is 4, plus 4, thank goodness those 4's cancel out, 64 over 48, and then over 2. 64 divided by 2 is 32, so it's 32 over 48 pi, and then simplifying, I can divide both of those by 16. This becomes 2/3 pi, which is our answer. Okay, quick recap. That was obviously just taking an integral. But the tough part here is figuring out what the area is. Well, it's a semicircle, so I immediately know it's 1/2 pi r squared. Okay, well, first thing is I gotta find my region, right? So I find my